So, hi everyone. So, we had started talking about Anova in the previous video lecture, and we did half analysis with respect to the analysis of variance, and particularly one-way Anova. Now, this particular lecture will be focused on the second step of Anova. So, once in the first step of Anova, where you were convinced that you can now reject the null hypothesis of equality of means, and you say that there indeed is a significant difference between the means of the different groups you're looking at, then you can move on to the second step. Just to give you a quick recap of the data set we're using, the independent variable, the categorical variable, is group. So there are three groups, group 1 and 2 and 3. And these three groups are physics students, mathematics students, and chemistry students. I have no bias against them. And then the dependent variable or the target variable whose means we're trying to look at is IQ score. So that's about the data set. And then I taught you how to go about ANOVA. We're going to analyze compare means, one-way ANOVA. So I had actually put it already. You can go through my earlier video lecture to get a grasp on it. So I put IQ score in the dependent list and group number in the factor list. You have to ensure that your dependent variable is continuous and independent variable is categorical, which could be nominal or ordinal. This should be a scale variable. Now, since I told you that ANOVA is in two steps, first one was the F test, which convinced us that there indeed is a statistical difference between the means of these groups. At least two groups differ, that means, okay? So F test doesn't guarantee that all the group means are statistically different. That just means that at least a pair of means is. But that F test is, I would say, an omnibus test. We also call it an omnibus test, OMNIBUS. Omnibus means about everything, you know. So F test doesn't necessarily now tell you which two means are statistically different, okay? It just tells you that means are statistically different, but which two, it does not. For that, we move on to the second step, as I have been pressing upon right since the start of this lecture. We call that post hoc test. Post hoc means after that. What that? That means the test of F test, which we've done already in ANOVA table. I'll go to the post hoc and we're gonna use TUK. Okay, so tick on TUK. So this is also the TUK HSD test, or HSD stands for honestly significance difference. Continue. And then in options, we wish to look at descriptives, and then the means plot. I'm just taking these, but I've explained this in the earlier lecture, but I'm not going to interpret them now. And then we have contrasts. Now, what does contrast do? I'll tell you. So contrasts allow us to obtain certain set of analyses. One could be, I want to compare one level of categorical variable with another. For example, I'm interested in knowing how are the IQ scores of group 1 different from group 2. Likewise, I can do it for group 1 versus group 3, group 2 versus group 1, group 3, okay? But this is not means, this is just the scores. Please don't confuse yourself between contrasts and the post hoc test. Post hoc test will test which two group means are statistically different, okay? And contrast will just test whether two groups are different or not in terms of their raw IQ scores, okay? Not the mean IQ scores. That is what I'm trying to convey. So the null hypothesis is different in both of these cases. I'll teach you how. So since I'm trying to look at contrast, and contrast can be used for any two comparisons. Now those two comparisons could be in this fashion. I can compare two groups simply, group 1 versus group 2, group 1 versus group 3, or group 2 versus group 3. Alternatively, I can also compare group 1 versus group 2 and 3 combined, and then one could be group 2 versus group 1 and 3 combined. Likewise, group 3 versus group 1 and 2 combined. So that ways contrasts allow us to make these contrasting comparisons on the dependent variable values of these categorical variables, which are groups. Okay, so let's say I'm interested in the contrast of please give me a second. I had already fed it, so it was just appearing. So please don't bother yourself with that. I'll teach you. Yeah. So I'm interested in making a comparison of group 1 versus group 2. Now, in contrast, when you're feeding, you need to ensure that sum of the coefficients on all three groups add up to 0. For example, when I'm trying to compare group 1 and group 2, I'll add 1 for group 1. So this is a coefficient for group 1. And I'll say -1 for group 2. And then a 0 for group 3. I have three groups. I wish to make a contrast between group 1 and group 2. So I'm going to put forth group 1 with a 1, group 2 with a -1, and group 3 with a 0, such that adding all of these coefficients, -1 plus 1 plus 0 gives you a 0. You have to ensure you give all coefficients for all the group numbers, okay? So that was about one of the contrasts that I'm trying to make. What another contrast can I make? Let's say I want to compare group 1 versus group 2 and 3 combined, okay? So now here, since I need to again assign three numbers such that those three add up to 0, so what I can do is I can assign a +2 to my group 1 and -1 to group 2 and 3 each. That will allow you to make comparisons between group 1 and group 2 and 3 combined. So I'll add 2, then -1, add, again -1, and add. So you can also look at both the comparisons. One is 1 - 1, 0, that is 1 versus 2. Another is 1 versus 2 and 3 combined. So I say continue. And also in post hoc, when I take 2k, I also have to choose a level of significance. So I'm choosing it to be 0.05. That's the 5% standard level. Continue. I think I'm done here. And we looked at descriptive, homogeneity, and means plot in the earlier lecture also. I'll just anyway tick them and click OK. All right. So that's your output. Descriptives we compared earlier. Homogeneity of variances we compared. This came out to be insignificant. We said that the variances are indeed not equal. So we had to go for robust test of means. Please go to my earlier lecture for that. So at least we're convinced that the variances are not equal in our group, okay, in our data set. And then Anova. So I'm saying that when this particular F test of the null hypothesis that all group means are equal gets rejected, we're going to move on to the second step, that is the 2-case test. That is your post hoc test, okay? So we're going to talk about post hoc as a step 2 in Anova. Only once you have taken care of this particular F test, this has been rejected, and you're convinced that indeed the group means are statistically different. We come over here and ask, okay, which two group means are statistically different? That is post hoc. Let's try interpret post hoc. So this is because we have three groups, we're going to have comparison between the groups. Each of the results appears twice. So for example, physics and math, again math and physics, one and the same thing, okay? So each of the results or each of the comparisons is going to appear twice in your table. you should be interested in looking at this significance level, okay? Alternatively, you can also check the asterisk mark, okay? So let's proceed. The null hypothesis is that the mean IQ score of these two groups is equal. Alternative is the mean IQ score of these two groups is not equal. Null hypothesis is always the hypothesis of equality, right? So now when I'm comparing physics with math, I see the significance level is 1. Also, there's no asterisk. That means this is not statistically significant, or I'm not able to reject the null hypothesis. The null hypothesis of group means being equal. So physics and math students, mean IQ score is indeed not statistically different as reflected by the level of p-value, that is 1. Okay. Then we compare physics and chemistry students. So physics students and chemistry students, we see p-value is 0. That is less than alpha of 5%. So we reject the null hypothesis of the group means of physics and chemistry students being equal. So we say that the group means of physics and chemistry students is significantly different. Okay. Likewise, you can make other comparisons of maths and chemistry student, which is also statistically different. Okay. Then chemistry, physics, and chemistry maths. See, results are appearing again. So you just have to look at this p-value and make comparisons that which group means are statistically different. That was about poster. Now, where is my contrast tests? Okay, remember, we made 2 sets of contrasts. Contrast 1 was, we're trying to compare the IQ score. I repeat, not the mean IQ score as in the post hoc test. I'm comparing the IQ score, the dependent variable of group 1 versus group 2. That is your contrast 1 as listed over here. My contrast 2 was, I'm comparing the IQ score of group 1 versus group 2 and 3 combined. Okay. So this is how you have to interpret. If your Levene's test of homogeneity of variances conveys to you that the variances are homogeneous, that is, you were not able to reject the null hypothesis of equal variances there, okay, then you're going to interpret the first part of the table, that is assuming equal variances. But in our case, since we could not prove that the variances are equal as p-value is less than alpha, and we rejected the null here in Levene's test, we're gonna say that we are assuming that variances are not equal. Okay, so I'll interpret that. Likewise, interpretation is the same. Okay, so assuming that the variances are not equal, my contrast one is statistically significant or not can be looked at this p-value. What is the null hypothesis? Hypothesis of equality. So hypothesis is, null hypothesis is group 1's and group 2's IQ scores are equal. Okay. P-value is 0.98. That's too big a value. So I'm not able to reject the null hypothesis. And I say that the IQ scores of group 1 and group 2 are just the same. Okay. They're not statistically different. And then we come at contrast 2. Contrast 2 is comparing IQ score of group 1 versus group 2 and 3 combined. Okay. Again, what is the null hypothesis? Equality. The null hypothesis is the IQ scores of group 1 and group 2, 3 combined are equal. Alternative is the opposite. They're not equal. And since p-value 0.011 is less than alpha of 0.05, I reject the null in favor of the alternative. Alternative was that the IQ scores are indeed different. So our contrast 2 is statistically significant. Okay. So that was about contrast tests. I repeat, it's not about the mean IQ scores, but simply the value of dependent variable, that is IQ score. Okay. And contrast tests can be made as per your wish. You want to compare 1 versus 2, 1 versus 2, 3 combined. I've spoken about all of that. And this was about the post hoc test. Okay. So one thing which you must keep in mind is that only once the Anova conveys that this null hypothesis of equality of means gets rejected, you're going to talk about the post hoc test. Otherwise, there shouldn't be any talk about post hoc test. Okay. It's very important to get through with your step 1 of Anova to come at step 2 of post hoc test. So that's all from my side. Thank you.